Hi everybody, this is Pre-Calculus Chapter 1, Part 4, and this part covers complex numbers. And we have already done complex numbers in Algebra 2. Like I said, this whole chapter is kind of a review. Alright, so to include the square roots of negative numbers, so remember we were talking about square roots, we use the imaginary number I. I is equal to the square root of negative 1, and we've done this before, so we've got I equals the square root of negative 1. So remember, if we had I times I, we're going to get square root of negative 1 times the square root of negative 1, which is equal to negative 1. Okay, so 2i's gets us negative 1. Alright, so the square root of negative 9. So what we're going to do is we're going to break these apart. So we've got square root of negative 9. That's equal to the square root of 9 times the square root of negative 1. And to write that, then we can pull this out of its square root. That's going to be 3. And the square root of negative 1 is I, so we get 3i. Alright, square root of negative 13 would be square root of 13 times the square root of negative 1. We can't do anything with square root of 13, so we're going to leave that. But this we can turn into I. And you notice how I is not underneath that radical symbol. There are several important sets of numbers with which you should be familiar. So we've already went over these last year. It's just kind of review. So our integers, these are going to be the whole numbers, positive and negative. So those are our whole numbers. Rational numbers are any number that can be written as a fraction with integers on the top and the bottom. So whole number on the top, whole number on the bottom. Any number can be written like 2 would be 2 over 1. That means that it is a rational number. Okay. All right, real numbers. This includes all the integers and rational numbers, plus the numbers that can be written as a fraction. Including the rational numbers along with numbers which cannot be written, cannot be written as a fraction. So that would be things like the square root of 2 or pi, right? Same thing with a decimal that goes on forever and ever. Or like 0.33 repeating or 32 repeating forever, okay? Imaginary numbers, that's going to be the number I multiplied by any real number. So anything with an I in it is imaginary. And then complex numbers. Complex numbers are the sum of a real number and an imaginary number. So like 2 plus 6i, that's a complex number. All right. Addition, subtraction, and multiplication with complex numbers. Treat I just like you would treat an x, except whenever you have an I squared, replace it with negative 1. Okay, super duper easy. Remember last year we just paired up all those i's and we turned them into negative 1s. So right here we got to add, and when it says treat it like an x, that means you can only add or subtract like terms. So that means we can only add imaginary numbers to imaginary numbers, and then non-imaginary real numbers to real numbers. All right, so here we got a 3 and a negative 2. We can put those together. 3 and negative 2 would be 1. And then we've got negative 8i, so our imaginary part, negative 8i, and positive 4i. So that would leave us with negative 8, positive 4 would be negative 4i. So that one is 1 minus 4i. Same thing on this side. So we've got 3 minus negative 2i. So now the big thing about this one is you have to distribute that negative sign. So whenever you're subtracting, you have to make sure that negative sign goes out. So this wouldn't be a plus anymore. This would be a minus, and then that would turn into a plus, right? There we go. So if we just change all those signs, then we won't get confused. So we've got 3 plus 2 would be 5, or 3 minus negative 2, right? These cancel each other. It's 3 plus 2. That part's 5. And then here we have negative 8i minus 4, or negative 8i minus positive 4i. So really it's just minus 4i. And negative, we're just going to add those two together. 8 and 4 is 12. So that would be negative 12i. So that's the answer to that one. 5 minus 12i. All right, this one we're going to multiply. And remember, when we multiply, we're going to have to do our little rainbow. So first we're going to multiply here. And so we're going to say 3 times negative 2, which would be 2 times 3 is 6. So that would be negative 6. And then we're going to multiply here. 3 times 4 would be 12, and that would be a positive 12i. Then we're going to multiply here. 8 times 2, this will be positive. Negative times negative is a positive, and 8 times 2 is 16i, and I'm stacking them. And then we're going to multiply here. Now, we're going to have a negative, and 8 times 4 is 32. And that would be I times I, so I squared. Now, I squared is really negative 1, so that means that it would be negative 32 times negative 1. Negative 1 just means change the sign, right? So it would equal positive 32, and all this I would be gone. Okay, so I'm going to write it over here and erase it from that other side. Now I'm just going to add this up. So I have negative 6 and positive 32, and that's going to be, let's see, 32 minus 6 would be 26, plus 12 and 16 would be 28i. And there's the answer to that one. Okay, this next one, we're going to do this again. We're going to multiply. So 7 over 2 times 7 over 2, which would be 49 over 4. Okay, then we're going to go times that one. So 7 over 2. This is a difference of 2 squares right here. So we don't really even have to do that. Watch what we can do. Remember, when we have a difference of 2 squares, our middle terms cancel, right? Because this is a plus, a minus, and that's a plus, right? So our signs, everything is exactly the same, just our signs are different. So that means this will be 49 over 2 times 2 is 4, okay? Minus 3i squared. So 3 times 3 would be 9i squared, right? Because what we did was 7 over 2 squared minus 3i squared, okay? And then that would just change the sign on that because I squared is negative 1, so that would be that's just going to be 9 times negative 1. Actually, negative 9 times negative 1, which would be positive 9. So we're going to end up with 9 plus 49 over 4. And then to solve that, we'll have to change that 9 into 4. So 9 times 4 is 36 over 4 plus 49 over 4. And we're going to get 85 over 4. And that's the answer for that one. So be careful with the ones that where it is a difference of 2 squares, right? So I didn't have, all those middle terms cancel each other. I didn't have to multiply 7 over 2 times 3i and try to figure out what that is, because I would have had 7 over 2 times 3i negative, and then I would have had 7 over 2 times 3i positive, right? So they would just cancel each other out. All right, next one is division of complex numbers. So in this one, we're going to have to divide. All right, so first of all, standard form is a plus bi, with a and b as real numbers, right? So when we write a complex number, meaning there's a real part and an imaginary part, our real part comes first, right? And then our imaginary part comes second. Okay, and we learned that last year. All right, we also need to know what a conjugate is. A conjugate of the complex number a plus bi is the complex number a minus bi. So all we're doing is changing the sign in the middle to make the conjugate. So if we had 3 plus 2i, its conjugate is going to be 3 minus 2i, right? If we had 6 plus 3/4 I, all we have to do is change the sign in the middle, 6 minus 3/4 I. And it always doesn't change from plus to minus. Sometimes it's the other way around. So what if we had 7 minus 3i? To get the conjugate of that, we're just going to do 7 plus 3i. Super easy. Just change the sign in the middle. All right, so what that's going to do is allow us to solve division problems with complex numbers. All right, so so to divide one complex number by another, we're going to express the quotient as a fraction. So first off, we want to write it as a fraction, 1 over the other. Multiply the top and the bottom of the fraction by the conjugate of the denominator. So we're going to take this denominator, right, and we're going to change it, multiply it by its conjugate. So we need the conjugate of the bottom, which would be c plus di, and then we multiply it by the top and the bottom. And we did this last year. So what that's going to do is it's going to simplify it. When you multiply anything times its conjugate, it gets rid of the imaginary part. So I'll give you an example of that. If we had 3 minus 2i, right, and we multiply it times its conjugate, which would be 3 plus 2i, right? It's basically a difference of 2 squares. We're going to say 3 times 3 is 9. 3 times 2 is 6i, and negative 2 times 3 would be negative 6i. See how those are going to cancel? And now we have 2 times 2 being negative. 2 times 2 is 4i squared. And I squared is negative 1. Negative 1 times negative 4 would be positive 4. It's a real number now. These two cancel each other, and 4 is 13. So that whole thing right there simplifies to 13. It's going to get rid of all of your imaginary numbers when you multiply something times its conjugate. All right, so then you're going to separate the quotient in the real term and the I term. Okay, so you're not going to leave them as one fraction. You're going to separate it. All right, so let's do an example. So the first thing we want to do is write it as a fraction. All right, so we've got 3 minus 8i divided by negative 2 plus 4i. Okay, so now we have to multiply that times its conjugate on the top and the bottom. So we're going to take our bottom and we're going to write the conjugate of that, which is negative 2 minus 4i. And then we're going to multiply it on the top as well by that conjugate. So I just changed the sign in the middle of the bottom one, and I'm multiplying it by the bottom and the top. And remember, a fraction doesn't change if we multiply the bottom and the top, right? Because a fraction is just a relationship. All right, so now we're going to multiply these. So first I'll do my top. So I've got 3 minus 8i times negative 2 minus 4i. And I'm going to do 3 times 2 would be negative 6. And then 3 times 4 would be negative 12i. Then I'm going to multiply here. Negative times a positive would be a positive. 8 times 2 is 16i. And then I'm going to multiply right here. That'd be a positive because we got negative times a negative. And then 8 times 4 is 32. And that would be I squared. And remember, I squared is really negative 1. So that means positive 32 times negative 1 would be negative 32. Okay? All right, now I'm just going to add up my like terms. Negative 6 and negative 32 are going to be negative 38. And then I'm going to have 12i, and my 16 minus 12 is going to be 4i. Okay, so there's my top. Negative 32 plus 16i. Now I'm going to do my bottom. Okay, so I'm going to have negative 2 plus 4i times negative 2 minus 4i. And this is where it should get rid of all of my I terms. So I'm going to have negative 2 times negative 2 would be positive 4. And then I'm going to have negative 2 times negative 4i, which negative times a negative would be a positive. 2 times 4 is 8i. Now here I'm going to have 4 times 2, which would be 8. And this one's going to be negative 8i. And then we're going to have 4 times 4 is 16. That'll be a negative 16, and I times I is I squared. Right? And then we know that that's going to be the same as negative 1. Negative 1 times negative 16 is going to be positive 16. All right. So now we have 16 plus 4, which would be 20. And our i's cancel each other out. So our whole bottom has been reduced to 20. Now we just separate those out. So we're going to have negative 32 over 20 plus 16i over 20. Okay. We can reduce those. So half of 32 would be, oh, that was supposed to be 38 down here. Whoopsie. Make sure you write the right thing. There we go, 38. So that would be 19 over 20, no, over 10. If we divide by 2, half of 38 is 19, half of 20 is 10. Plus, let's see, we could divide both of these by 4. That will be 4, and that will be 5. So we're going to have 4i over 5. And that is the answer to that one. Now we could check and make sure we got it right by multiplying it back out. So we could say negative 2 plus 4i times negative 19 over 10. Oops, that's negative. Blah, blah, blah. But that's how we get the answer. So they've got multiplying it back out. It will be negative 2 plus 4i times negative 19 over 10 plus 1/5 I, and that should equal this one. So you take this one and you multiply it by your answer, right? And then you should end up with that, because it's that divided by that, right? And there's our answer. So if we multiply them back out, then we come up with what we started. So that's an easy way to check. All right, so let's review some of these concepts real quick. So this is the kind of stuff that I pulled from your homework. So on this one, we've got the square root of 36 over 16. Well, the square root of 36 would be 6. And the square root of 16 is 4. So that's 6 over 4, which would be 3 over 2. Double check that and make sure. All right, this one is just 0. So this says for each number specify, oh, okay, so I was doing that totally wrong. I'm supposed to write what it belongs to. So for each number, specify which set of numbers it belongs, which set the number belongs. All right, so this first one, this can be written as a fraction. So it's not an imaginary number, because we just said that it could be 6 over 4. That's a fraction. So it is not irrational. It's rational. And it is a real number, right? It's not an imaginary number. And it is And that's pretty much it. All right, so we've got our choices are integers. It's not an integer because it's not a whole number, right? It doesn't reduce to a whole number. It reduces to 3 over 2. Our choices are integers, rationals, reals, and complex. And remember, complex is an irrational number with a real added. It is also complex because pretty much any number can be a complex number, because we could say 3 over 2 plus 0i, okay? So pretty much any number is a complex number. We just didn't express the I part. All right, 0 is going to be an integer. Is it rational? Yes, it is rational. Is it a real number? Yes, it is a real number. And it is also complex. All right, -3 is an integer. Yep. Is it a rational number? Yes. Remember, rationals are ones that can be written as a fraction. We can write that as 3 over 1. It is a real number. It's not imaginary. It doesn't have any I part. It doesn't have any square root of -1. And it's a complex number. Because any number can be a complex number. That's just the real part. And the imaginary part is 0. All right, square root of 7. Is square root of 7 an integer? It's not going to be an integer because it is not a whole number. Is it rational? No, it is not rational because we can't just say what's the square root of 7. That one's going to come out as a decimal. It is a real number because there's no -1 in here. If it was square root of -7, then it wouldn't be. And it's complex. All right, 3i, that's not an integer. It's not rational. And I don't think it's a real number either because it has an imaginary part. So that one is just going to be complex. All right, so as you do these in your homework, go over them one at a time, think about the definition, and make sure it applies to the number that you're looking at. All right, this one says put each number in standard complex form. So basically that means that if you've got anything in a radical bar, you want to try to get rid of it. Get rid of the radical. Okay, so the first one is supposed to be the square root of 9. Put my square root box, my radical sign there. Okay, square root of 9, which would be 3. So that part's easy. 3 plus the square root of 7. There is nothing that we can do to that one to simplify it at all. So I'm pretty sure that's just the answer there. So for this one, you would just write 3 plus the square root of 7. This one, we could pull out this negative square root under there. So we could say 4 minus 5. Okay, so times square root of 6 times square root of -1. All right, so this part's just going to be I. So we're going to have 4 minus 5 times the square root of 6, I. 6 times 5 would be -30. So that would be square root of 6i. Let's see. All right, so that one's going to be, yeah, we can't simplify any further than that. So 4 minus 5 times the square root of 6i, and that's as far as it'll go. So there's that one. All we did was pull out that imaginary number I from there. All right, perform the indicated calculations. All right, so this one we're multiplying because there's no sign right there. All right, so we're going to multiply this one. So we're going to say 2 times 4 would be 8. That's a negative 8. 2 times 3 would be 6. Then we're going to multiply right here. 7 times 4 is 28. And then 3 times 7 would be 21. And that is I squared. And we know that I squared is really negative 1. Negative 1 times 21 would be negative 21. Now we're just going to put together our like terms. So that would be negative 29. And then we would have 6 and negative 28, which will be negative 22i. All right, double check and make sure I got that right. Negative 29 minus negative 22i. So that's how you do that one. This one we're subtracting. So we've got our real part here and here. And remember, we got to distribute that negative. So that makes this plus 4, right? And that makes this one be a negative. Okay, so we got to think about it like that. So if we have 2 minus negative 4, it's going to be 2 plus 4 is 6. And then we have 7i minus 3i, which would be 7 minus 3 is 4i. Okay, so that should be the answer to that one. All right, and then this one is a division one. So on this one, I don't have a complex number at the top, which all numbers are complex because they'd be plus 0i, but I don't have any imaginary part of that top number. I still need to multiply the top and the bottom times the conjugate of the bottom. So our bottom is negative 12, and the conjugate is negative 12 plus 7i, so the conjugate would be minus 7i. And then do that on the top. All right, so for our top, we're going to say 5 times negative 12 minus 7i. 5 times 12 would be negative 60. And then 7 times 5 would be negative 35i. So there's our new top. Negative 60 minus 35i. Now we're going to do the bottom. Negative 12 plus 7i times negative 12 minus 7i. Negative 12 times negative 12 will be positive 144. 12 times 7 is 84. Positive 84i. 12 times 7 again would be negative 84i. 7 times 7 is 49. Negative 49i squared, which would be negative 1. Negative 1 times negative 49 would be positive 49. So these are going to cancel, and I'm going to get 144 plus 49. 13. 1 4 is 8, 9. 193. Okay. And that will definitely reduce. So first we need to separate those. So we're going to have negative 60 over 193 minus 35i over 193. And did that reduce? Let me look in the answer key. 60 over 193. Actually, they've got a positive 60 right there, so how did I get negative? Oh, that's a -5. Whoopsie, negative times negative is a positive. And that means that this one should be a positive as well. So that makes that plus. And get rid of that. So really watch those negative and positive signs. If you don't carry that negative down here, then you get problems. All right, and that is the answer as it shows in the back of the book. All right, so hopefully that'll help you do your homework. There are quite a few of them on this one. There are 39 problems, but that's not too bad. All right, that is it for lesson 4.